Okay, quick question. If I'm going to put that back up on the board here in a second, but if I'm imagining a function in my head, and it can be a nice smooth polynomial, or it can be a rational function, and I see on a table of values that it changes signs. There's only two things that could have happened to allow me to change from positive to negative, or vice versa. What's one of them? I could have crossed the x-axis, right? So zeros is fine, but if you want to be more specific, zeros of odd multiplicity is what you would really specifically say. It showed up once or thrice or 5 times, doesn't matter. If it's an odd number, it crosses and you would change sign. But it doesn't have to be a zero or a solution. It could also be a vertical asymptote. Now, still can't get over the fact that people were claiming that they would rather graph them, because I don't fully believe you, but we're going to look at this real quick. Now, yesterday, we were trying to solve this inequality from the get-go, and I'm just catching this up because you guys have all this written already, correct? Okay, so remember, we don't have a 6 product property, we have a 0 product property. So as soon as we get this less than 0, all we're after is finding two things. Find, are there any vertical asymptotes? And it could be holes realistically, but we'll look at that one. Yes, ma'am. Please go back to the office. Red, please escort Casey down to the office. All right, so as we're looking at this, we only care about the vertical asymptotes and the zeros, the only places where I would ever be concerned or even expect this thing to change. Now, in this problem, how do we know there weren't any vertical asymptotes? Good. You would have an x in the denominator. That's the only way that you'll get a vertical asymptote. Now, that's not entirely true because things like natural logs or just logarithms in general also have asymptotes, but those aren't polynomials, so we're not there right now. Okay, so yesterday we went through the process, we found the roots, and we could graph the function, but we don't really need to if all we're doing is answering this question. So we're going to make use of our wonderful, and this is the first one we've done, right? Awesome. We're going to use kind of a graph, and what I mean by that is we're just going to use a number line. We're not going to worry about the y direction, not fully. So here we go. We're going to put a number line here, and I'll think of how I want to annotate this. But there's only two numbers that we've found that this function right here could possibly change value. There's no asymptotes, right? So there's only two roots. What are the only two numbers that it could possibly change at? -1 and 6. These are the only numbers that I'm going to put on this number line. Now, to be more clear, and I think that there's probably not a whole lot of confusion, I'm actually putting infinitely many numbers, but I'm only writing 2 of them because number lines have all the numbers. So check it out. As long as we're in order, -1 and 6, we should be okay. Now, we did not name the function this time. Depending on the situation, I'm going to assume that we're working with a function named f of x. Now, that is a pure assumption. You could write g of x. I will try to make sure that we get names for them. But I'm just going to work under the assumption that we had a function f of x. This is f of x right here, just for the record. Okay. Now, when I see this number line, and whether you're aware of it or not, this is the actual x-axis that we would graph on. I just don't care about everything else that happens, not as much. How many intervals did I just split that number line into? So let me rephrase, because I think I heard somebody murmur or whisper or quietly state, however you want to word it. These are all the real numbers. I see how many sections of the real number line on the board right now. So I think it's 3. Now, I agree that it's 3, but if you don't see that right away, if when you hear that it's 3, do you see what I'm referring to yet? Okay, the intervals, and you don't have to write this, but I do want to make sure we all have it. Up to you if you want to write this, not part of the problem, just cleaning it up. This interval here is where? Like what range of x values is this? Less than -1, I'm cool with that. Or we could say it's the interval -∞ to -1. Do you agree with that? Now, we don't have to write this. You can, like it's good practice, but this is not going to be influential in actually solving the problem. We're just making sure we all agree with this. Lay, what's this interval? I agree with that. Give me some numbers. So 0's in here. Let me rephrase this, because you're giving, like, you did exactly what I asked, so I can't fault you for that. What's the interval from here to here? Starting at -1, but we don't touch it, and going to where? Good. That whole middle section. And I'm cool with that language of the middle. And this last one, we should. Okay. Again, not part of really solving the problem, just part of making sure we can all identify the same thing. There's very clearly 3 sections if we make sure we can view it like this. Now, I don't care what the actual function does. I know it's 0 here and here, and 0 is neither positive nor negative. So all we have to do is find 1. And we're going to use that idea of multiplicity over and over and over. Is anybody in here maybe feel like you're not 100% on what the idea of multiplicity is? Cool. That happens. Really easy. Multiplicity, by definition, is just the number of times a 0 shows up. Okay. Each of these, like how many zeros total did we find? And how many times did x equals 6 show up as a solution, a 0, a root? 1 time, right? Because we only wrote x equals 6. For example, if we had done this, and you don't have to write this, but if we had factored something that came out like this, we would have maybe not write it, but do you agree that here are my roots? And now it showed up twice. This has a multiplicity of 2. Like that's what that multiplicity number is. If the multiplicity of your root is odd, it crosses the axis. If it's even, it touches and turns around or bounces, is what you guys proposed. That's it, the number of times. If the root shows up odd number, cross, even, touch and turn, or bounce. Now, the good news about these problems is that we don't need very much specific information just to answer this. Now, as I look at this, I'm going to use these in my multiplicity trick as a huge shortcut. I need one number that's in any of these 3 intervals. Preferably the easiest possible number, but any number will do. 0 is the number that will do, and it's also the easiest possible number. Now, does 0 live in the left, the middle, or the right interval? So for this one, I am going to physically check it. I'm going to say, okay, let's let x equal 0. And I'm going to plug it into my function. Here's the cool thing. I don't care about the number that it spits out directly. I only care about the sign. Not like the sign function trig stuff, but whether it's positive or negative. So let's check this out. Here is a version of f of x, or here's the factored version of f of x. These expressions here and here are the same. They're just written in different forms. Which one would you rather plug into, the general or the factored? General for 0, me too. Any other number, I'd probably do the factored one because it's easier, but really doesn't matter. So check it out. If we do f of 0, I get 0 squared minus 0 minus 6. It's negative 6, right? Don't care that it's negative 6. I only care that it's negative. Not going to even write the number down. I'm going to simply up here put this symbol. Or you can physically write the word negative. This is just the minus sign in parentheses. Now notice, if we were possibly talking about multiple functions at the same time, I would have f and maybe g or a different function. I want to make sure that these are clearly labeled. Now, I think this is the only one that we really need to check. Could you give me a number to check here in 6 to infinity? Give me a number in 6 to infinity. 7 is the natural choice. So you could check 7, but I don't think we need to. We will just to verify. This was a root, and how many times did it show up? Once, and that's an odd number. So if it had an odd root or an odd number of that root, it crossed. If it was negative in the middle and then it crossed, now it must be, I think so. Now, I know so for the record, but that's with multiplicity. You should use this every time. You should get used to it because we're going to see this show up again and again throughout this year, next year. If you don't like that idea yet, yes. So because this showed up as a x-intercept one time, it means it actually crosses the x-axis. Now, when I'm talking about that, here's the difference. If this is 6, there's a possibility that a function could do this, and it crosses, where I can very clearly see it's positive, and now it changed to negative. Or that's if it's an odd number of times. But if it had been an even number, so 2 or 4 or 6, my function could have done something like this, or would have done something like this. And now it's positive and positive. And I'm using that to get this. Did I see a hand or was it a stretch? Okay, do you want to make that a question? Okay, so no, you're good. The 0 in the middle I'll show my scratch work. Instead of just saying 0, we're going to try to evaluate f of 0. And that's much more specific. So now, if I plug it into my nice form of my function here, it would get 0 squared minus 5 times 0 minus 6. And I know that that's really equal to a negative 6, but I don't care about the 6 part necessarily. I just care about the negative, because I don't care if it's negative 10 or negative 12. They're both negative. Okay. Now, in this sense, the multiplicity, huge, you should use it. It will save you a ton of time. But if you don't remember it or it doesn't click yet, it's not the end of the world. If I pick a 7, and now I'm going to show you guys because we didn't do it before, are we all okay with saying this general and this factored form are the same? Like, they look different. If I said find f of 7, most people would probably default to this. It's way easier in the factored form for any number but 0, because check it. If I look at the factored form, what's 7 minus 6? 1. Now, in my head, I don't even care that it's 1. All I care is that it's a positive 1, is what I'm thinking. And then here we do 7 plus 1, 8, but it's also a positive 8. And then in my mind, and even if I'm doing this on paper, I won't always necessarily do the numbers. But what I realize is that if I take f of 7 into that factored form, it leaves me with a positive times a positive, which is a positive. Don't care at all about the number, only about the sign. Okay. Could we pick something in this interval? Negative 2 would be the option, right? If we tried negative 2 minus 6 gives me a negative. And what about negative 2 plus 1? It's a negative. And what's a negative times a negative? Positive. If we hadn't used that number, though, pretend that we never once mentioned negative 2. Could I have arrived at positive still? If we never talked about testing a number here, how many times does x equals 1, negative 1 show up as a root? Is that an odd number or an even number of times? So one time, it's an odd number, which means does it cross or does it touch and turn around and stays the same? And if it was negative and it crossed, now it's good. We can use the multiplicity, and I would encourage try to use the multiplicity, but even if you don't get it, you can just pick a point in each interval. Huge warning, real quick. If it's an asymptote, you did not find a solution, a 0, a root, you can't use multiplicity across asymptotes. We'll see that happen too. Like, that idea might not click right there, but we are about done. Now, if you want to graph the inequality here, not with shading and stuff, we can. We were told, and we identified rather, in the very beginning of this problem, very first step, that this meant negative, right? Does my solution include negative 1? No. How come? Good. Negative 1 is equal to 0. If this had been less than or equal to, I would have included it. But if you want to graph them, I'm never going to require you to. But open circle is how we indicate we don't touch it. And from this open circle above my root, if I want the negatives, do I go to the right or do I go to the left? I go to the right. And I should have said if I want the negative outputs, that's these signs here, then we get this. And I can see my graph. Now, whether you draw this graph to indicate it or not is entirely up to you. The real part that I care most about is we need a set. So we see it's the set of all x such that I know where x lives. And you can do the interval if you'd rather. If you're going to just use the interval notation, here's my only concern. And we'll come back. I'll write that one again here in a second, so don't erase it. People are going to be tempted, and I'm dealing with this in calc right now, which is the only reason I'm hitting it so hard. People are going to be tempted to write this as your answer. And I don't disagree with it, but it's really unclear. It certainly looks to me that you've just given me a single ordered pair, right? It looks like a point. If you want to use this interval notation, I'm cool with it. But I'm going to start requiring, if you're going to use it, add the x in the set of. This takes out any ambiguity. Because if I ask for like points on it and I ask for the inequality, I have no idea what you're answering here. If you just don't want to deal with that, the alternative is just set builder. It's a set of x such that x is stuck between which two numbers? Negative 1 and 6. So I'm just going to stick it between negative 1 and 6, and then we're going to work out the inequality symbols. Is x always bigger than 6 or less than 6? And is x always bigger than negative 1 or less than in this middle region? Greater than. And there it is. We can do it as a single compound inequality. Okay. Now, I want to show you guys the real benefit. And I don't think that anybody's going to hold the opinion still, but it really surprised me and I just can't get over it. You could solve this by graphing it. I'm not going to graph this out right now. Like, it's not a terrible one to graph, but I do want to just look at the graph of it. And we'll see that maybe we kind of did, just with a way less accurate graph. So our function was x squared minus 5x minus 6. X squared minus 5x minus 6. Now, for this, here's the actual graph of the function. But check it. On our number line, I didn't have a y-axis. I didn't need it. But these are the numbers that are there, right? We graphed this function, kind of. We never actually drew the graph. But do you agree that when I look at this picture, without actually getting the points and doing it, I can see very clearly that between -1 and 6, it is below the axis. Now, essentially, or exactly, what we've done is we've made sense of everything that was going on without having to draw the graph. Notice, if I just take this picture, and the size isn't going to be right. Well, it's actually really close to right. Is that the same number line that we just drew, but I didn't have the red part? And instead of giving actual values, we just said it was negative. It's the same as graphing the whole function, but we're saving like the 2 or 3 minutes that would actually take to graph it. If you want to graph the whole function, you can. You don't need to. Okay, another one together, or do you want one more together? All right, we're going to bump it up though, and I should probably get a Precalc book. It's awesome.
For clarification, you chose x, that answer over there, because it makes our f of x equation true.
Yes, so it will eventually, like it's the same here, but we used this one because we don't have a, is it greater than 6 or less than 6 property, but we do have a 0 property. So if we know where it's 0, we just look on either side of it. Okay, did that clear it up? Okay. All right, so let's do another one here. Oh, all right. Nice, easy problem. I want to know, when is it true that 2x cubed minus 3x squared minus 32x is greater than -48? All right, I am going to help with this one, and we're going to do it collectively. But I'm going to give you guys the next 60 seconds or so. Chat with your nearby people, get an approach ready, because I'm just going to start randomly firing out random numbers to call on people. So talk with your neighbors, get an approach, and we'll deal with it. Cool. 60 seconds from right meow. As we're looking at this, and that calculator's dead. First thing we do, and I'm just going to let random people call out until they don't. Let's move this, because I don't have a way to deal with -48. But if I add 48 to each side of this equation, we get this wonderful thing. 2x cubed, I hate that 3. 2x cubed minus 3x squared minus 32x plus 48. All right. Now that's greater than what at this point? 0. And I'm always going to make this note. What does this mean? Greater than 0 means, are you sure? Positive. There we go. If a number is greater than 0, it means that it's a positive value. Okay. Now, at this point, do we have asymptotes? I'm confident we don't. Dolan, I think, is confident. Why don't we have asymptotes? There's no x's in the denominator. There's no denominators for that point, but there's no x in the denominator. So it means we don't have to worry about that. To get the roots, we get some options. We don't have to do it the way that I want to do it, which I'm fine with. Who wants to tell me how we're going to factor this? Group it. If I see a 4, like even number of terms, I'm going to try grouping immediately. This I don't like. Because right now, if we just try to group it, there's an issue. And I'm going to make a couple mistakes. Don't just blindly copy what I'm doing here. If I try to group it without changing anything, that's probably your first group. Yeah. Is this your second group? No. So this is my second group? No, and that's what I don't like. Oh. Like, I can't just group it and now suddenly change it to multiplication. I'm going to make this a plus a negative so that I can avoid that issue. Now, you might have just already done that and not even realized that it would have been a mistake otherwise. And if it's just so natural at this point that you did it automatically, I'm psyched about that. Okay. Now, for the rest of this problem, I'm not going to work greater than 0. I'm just going to switch between equals because I don't really care. I already know what the greater than 0 meant for this problem. What comes out of this group? So x squared leaves behind what? 2x minus 3. And then what should I divide this by or factor out if you'd rather? Love it. Negative 16 and 2x minus 3. Now again, I'm just going to set this equal to 0 because at this point in the problem, equals, I only need roots. Like the inequality part, we've already tackled. I just mean positive. I only need roots. And you only find roots by solving the equation when it's equal to 0. Okay, one of my factors, Davian. I have no idea how hardcore your factoring has been so far this year. Can you tell me one of the factors? So I'm going to help you. And it's okay if you can't. Are you cool with where we're at on the board right now? So check it out. Do these match? That's a factor. So immediately I'm just going to turn it around. What's one of the factors? Good. Not 13, minus 3. Abijah, can you tell me the other factor? The stuff that is in front of our groups that matched. Love it. X squared minus 16 equals 0. Okay. Now here we're at a weird little part where we might all take a slightly different path. Me personally, I would keep factoring. But we don't have to keep factoring. We could use zero product property here. You would have to add 16 and take the square root, and you might miss a plus or minus. So to just avoid all that, we're just going to keep factoring. Does this one factor any further? Just the first one. You said yes, we should. What were you going to try to factor out of this? Okay, so if I ask the follow-up of, okay, what do we factor, and you can answer it, you're going to change your answer, I imagine. Like, right now, this thing is prime. And there are some goofy things that we could do to fix it, but we're not going to worry about it. Like, anybody look at this and see it's a difference of squares? Is it a difference of squares, though? So not a nice one, but is it possible to take a square root of 2 and the square root of x? They're not nice numbers, but root 2 and x, right? Or root x. Is it possible to take the square root of 3? It's not nice, but it is. It's root 3. This is a difference of squares. We just don't typically do it because we don't need to go down further. I don't know if that was a terrible thing to say in hindsight. Scratch that. Disregard. Just ignore that. We'll see it again. Okay, this one at this point is linear. I can't do anything to it. It's prime. Doesn't go any further. What about that one? One more time? It's not a perfect square. It's a difference of squares. Okay. Do I just magically leave this one behind? He doesn't need to come along anymore? No, we never leave any of our factors behind. 2x minus 3. So embarrassing, but I don't remember how to factor it. Go ahead. X plus 4, x minus 4. You do the order exactly opposite from me, but it doesn't matter. Okay. Now, a couple things I just want to highlight. How many factors did we just find? 3. And how many roots are we going to find? How many should we have found? Why? Good. The degree of this function is 3. The fundamental theorem of algebra and the corollary to it, rather, tells me there's 3. I'm not going to show the work. Can you guys tell me the roots? So negative 4, 3 halves, and 4. And I don't really care the order that you wrote them. I just wrote them sequentially so that when I put them on the number line here in a second, I put them in the right order. If you mess up the order on your number line, but everything else goes well, you're still going to get the problem wrong. Like, it's an easy mistake to make, easy mistake to fix. So, just to be ultra clear, right here, and I've put the parentheses around it, but this is a version of f of x. This is the factored version of f of x. These are the same thing, one's just different form. So I'm going to do what with these 3 numbers? Or rephrasing, where should I put these three numbers? On a number line. So here we go. And I have -4, 3/2, and 4. Okay. Were any of these asymptotes? Nope. So that's a good sign. And I'm only asking that because if they're all roots, then I think we can employ the idea of that multiplicity. Each of these roots showed up how many times? Each of them only showed up once, right? And in any of those situations, 1 is a what sort of number? Odd, which means I know the graph will do what? Cross. Now, this part, because we're not going to do a ton of work with it, there's not a lot of writing that goes into it, which is why we're speaking about this and making us repeat it over and over and over. How many intervals did we just cut the real numbers into? 4. And you don't have to shade it, but there's 1, 2, 3, and 4, right? I can see all 4 of them right there. Okay. I don't care which interval it is as long as it's in value inside of the interval. It can't be at any of those 3 numbers that we've written down. I think that the easiest possible value lives here. Okay. What's the easiest possible number that we could plug in? 0. Could you pick other numbers, though? Yeah, you pick whatever you want as long as it's not any of these 3 numbers. Cool. I'm going to pick a 0, and 0 lives in this interval, right? So when I write this, I just write the 0 here to indicate this is the number that I'm checking. If you are in the habit of putting 0 and doing this, don't add any more dashes to your number line. All it does is muddy the water. You can write the 0, don't add any other dashes other than that. Cool. All right, so here we are, 0. If I plug it in, I can plug into this option A or this option B. It doesn't matter. 0 is the only number that I would choose A for. And you can really use any of them, and I'll just show you. I like A because 0 minus 0 minus 0 plus 48 is positive 48. Okay, if I use 0 here, I'm going to get positive again. I'm not going to bother to get the number here at all. 0 minus 3 is negative. So a negative times a positive times a negative. Negative times positive is negative, times another negative gets me to positive. And it's like 0 is not nice for this one. But I know it's positive here. So I'm going to go, ooh, too bold. Positive. I'm not going to.
Could you also plug it in for 2x minus 3 times x squared minus c?
Yeah, absolutely. You could have used C. It felt weird. I didn't even think about doing it because I had start and end. But yeah, anything that's equivalent in the middle is you're like, this one would have also been okay. That's a weird one to plug in too. But yep, these are all equivalent statements. Absolutely. And we'll just check. Negative times a negative is a, and it still works. Okay, I'm not going to check any other numbers. And I'm going to use that fantastic M word to help me with this. Multiplicity. If each of these roots shows up once, it means I cross everywhere. If I work from here and I go left, if I crossed over an x-axis, I'm now what? If it's positive and I cross this x-axis, negative here. If it's negative and I cross the x-axis here. Okay, this question, from the very beginning, we were looking for where it was what? And that question, I don't have a way to say whether it's negative 48 or bigger, but I do have a way to say it's 0 or larger, which we agreed at the beginning meant what? Positive. Are there places here where my graph is positive? Yeah, I don't need to see the graph. I know that it is. Where are those places? X such that, and we can even mix these methods if you want. Do you guys prefer interval notation for most stuff? Or do you like the inequalities? Okay. Interesting, not what I was expecting. So this little range here starts at which x value? So x must be greater than that, but simultaneously x must be less than another number. 3/2. That is this interval right here. And if you don't like the inequalities, I'll write the other one in a moment. Or there's another option where it can be positive. So I'm going to change it, but I agree with you. I would say x is greater than 4, but they're the same thing. Okay, this is like my preferred way, maybe. I don't know that I really have a strong preference. I'll I'll tell you, I do prefer the set notation, but I think an easier answer would be x such that x is in, and we could do the same thing from -4 to 3/2, and we'll tie that together with 4 to infinity. These answers are the same answer. This is my set builder inequalities. This is my interval. Either one is cool with me. I have no real strong preference. Okay. Do they feel okay? Feel terrible? Anybody still think you'd rather graph the whole graph to do this? Could you? Yeah, in fact, if I do this really quick and don't add anything to yours, let's see, 3/2 and 0. This is about where the y-axis would go, I think, roughly. And I'm just going to graph over top of everything. Do you agree that's about where y equals 0? So at 0, we said it was at positive 48. So my graph would be up here at 48. And then I know it's 0 here, and it's 0 here, and it's 0 here. And using multiplicity and the fact that it's a cubic function means I know it goes down to the left. So I know it's going to do something like this. Don't know what it does. Up to the right, there's my graph. I don't need the whole graph to answer the question. I can see what's happening. Cool. If that was way too fast, I'm okay with that. You don't ever have to graph it. I just wanted to highlight that it's there. Okay. So here's the big decision. What have you got going this weekend? Where? What is that? Is that a teen council thing? Okay. I don't know about this. What is it? PM? Kind of late. What is it? Oh, right. Okay. Here's what I'm willing to do. Do you want homework? Really? Okay. So here's the deal. We're going to keep working 5 to 8 more minutes. We'll have a couple down minutes at the end. I won't give you homework over the weekend, but we're going to keep working all the way up until like the end of the hour. Cool. It means on Monday, bring your work hats because we're going to be doing some work. Sweet. Okay, I'm actually going to give you guys a couple to do on your own, but I'm going to change the example and we'll name it after the fact because if I give you the name right now, you're going to know exactly what to do. So example. Oh, cool. Here we go. On A, I want you to solve for me. When is it true that x squared plus 6x is less than -9? Once you have that one and feel good about your answer, I want you to do one more for me. It's B, but check with me on A first. X squared minus 2x is greater than or equal. Yeah, we'll say greater than or equal to -1. Cool. I want you to do A. Check with me. Check with your neighbors. Collaborate on all that good stuff. Once you have an answer on A, go ahead and try B. And I'm actually going to end the video in just here. But if you're watching this on the road, go ahead and start working it. Pause the video now, and you will see a detailed in 3, 2, you know what to do, go. Yes. Now, here's the deal. The reason that I didn't name this example is because the name of it is Weird Solutions. And I didn't want you to already know that they were going to be weird before I gave you the example. Because there's something strange about it, right? Okay, so let's figure out, and I want you guys to tell me what's strange about it. Here's my number line. And I only wrote it once, but did it really show up twice? So you can write it once if you want, as long as you're mindful of what it means. If you need to write it twice to remember it, I'm cool with it. What number goes on my number line then? Just -3. It's the only number. Now, there's a weird thing that's going to happen here, and that's okay. What's the easiest value I could possibly plug into this function? 0, it's on the right, correct? Okay, so if I did 0, I'm going to plug it into this right here. 0 plus 9 is a positive. Don't care that it's 9. Like, I know it is. I don't care, though. I just care that it's positive. And this root right here showed up how many times? Twice, which means, like, and I wouldn't have you do this, Do we all recognize that this is a parabola? So if I added a y-axis in here at 0, and you should not do this, but I just want to highlight for this, I know then that my parabola is going to do this, it's do this and this, right? Now, I don't care about the actual y-axis, but I wanted to make sense of what was happening. And it shouldn't have been, I was goofed up there. What did I have? That's not right at all. It's this. Yep, and that's what I'm trying to highlight. If it's an even number of roots, which it was, then it bounces. So if it was positive and it bounced, what would it still be? Positive. Now, legitimately, and I'm not even just like, I think sometimes I do try to be nice, and I always try to be nice, just for the record. But it's not me just being nice. If you don't get this right now, that's okay. It's a time saver. If we don't understand what happened, all you need to be able to do is give me any other number here. Any number here. -4. So if we check -4, and I'm going to use my factored version, -4 plus 3 is -1 squared, +1, and it's positive. And I can get the same value. That multiplicity is super convenient, huge time saver, but we don't need it. But here's the weird part. That first part was kind of weird, but now it's especially weird. At the very beginning, if we make this a 0, it meant less than 0, which is negative, right? Is it negative here? Is it negative here? Is it negative here? So if you say yes, be really careful. -3 is when my function equals what? And is 0 positive or negative? Nope, so it's not negative there. So where's it negative? Like nowhere, right? There's no solution to this problem. Okay, that is a weird solution. Like it's strange compared to the other twos. Weird solutions. Okay, this one, very similar problem, I think. I'm going to add what first? And did you guys finish this problem, or do you still need a little time? Okay, we'll meet back up. I think realistically, we will talk about this problem together at the start of class on Monday. Whenever you get an answer, I'm not going to show mine yet, but I'll see you guys on Monday. Don't leave 2 minutes early, but I'm just going to end the video. P.S. I'm super cool. Everybody wishes they were as cool as me. Good luck swimming.